Okay, now let's see how can we get the antiderivative using substitution. So the idea behind the substitution is that if we have a composed function, that a function is inside of another function, basically the derivative of this will be the derivative of outside, including the inside as it is, no change there, multiplied by the derivative of the inside function, right? Now, what we need to do is to substitute w by what we believe it is the inside function. Then we calculate the derivative, and then we do the substitution. For example, we have this integral. This is not the finite integral. This is just a general integral. We say, okay, I will take this x as my inside function, and if I substitute it by w, then the derivative of w will be this 3x squared, right? So we have that here. We have the differentiable here also. This is my differentiable of w, and then I do the substitution. And of course, now we know by the theorem of calculus that the integral is the antiderivative, right? So basically it is the sign of w. So sign of w is, if we get the derivative, we will get cosine multiply plus a constant, because it's not defined in any range, right? Now let's do another example here. So what will be, if I have this integral, what will be the variable that we should substitute here? I will say that we should get w equal to the cosine of theta, right? Which is this one. Then the derivative of w, what is the derivative of w? It will be minus, right, sine of theta by the derivative of the theta, which is just that, right? Then what? But here we don't have any negative sign, right? So we can move this to this place, and we have sine of theta, right, by the theta. Now this part is here, this part is here. So if we do the substitution, we have EW, right, the W, and we have a negative, that because negative, like multiplication by -1, it is a constant, we can put it outside, right? And the antiderivative of E exponent of W is exactly the same. So we have this exactly the same with the multiplication with the minus 1 plus a constant, right? Let's do another example here. Let's do this one. What will be my W here? My W, I will say that is this part that we have is 1 plus e to the exponent t, right? The derivative of this one will be, this is a constant, it will go away, this will remain exactly the same, right? Multiplied by the derivative of the integral function, which is t, so it's like that. Then what? Let's do the substitution. This part is exactly this part that we have here, right? And this other is the w that we just took for the substitution. So basically we will have 1, right, like this, multiplied by W. And what is this? This is the logarithm, the natural logarithm, right, of W plus C. And okay, W we can still substitute it back by the initial, right? So we will have this of 1 plus E T, right, plus C. And this will be always positive, so we can remove this absolute value if we want. Let's do another, a different one. And by the way, in this one, in my previous, we can also substitute this back, right, to e to the cosine of theta plus C. That will be the final solution for this one. For this one, what is this? I can rewrite that using the trigonometric and say this is the sine theta by cosine theta, the derivative of theta. And if I do my substitution W, I will say W will be cosine of theta, right? The derivative of W will be sine of theta, right? Then I can do the substitution. It will be minus the derivative on W, and that is exactly the same as we have it here. In the previous one is a logarithm, right? Minus, because this minus will go away outside of the integral, and then multiply it back by W, right? And if we substitute it back the initial value of W, we will have that this is a negative logarithm of cosine of theta, right? Let's do the last one. What do you think will be the ideal W for this one? I will say the cosine of this. Basically, this is a whole function that I have another function inside, but I am not carry out the exponent tree. I will just say the cosine of EX, right? So the derivative of W, what it will be? It will be the derivative of cosine is this one, sine. The E is exponent, I will keep it as it is for now, right? Multiply it by the internal derivative of the exponent at the x, right? And we have that all these elements here, so we will have this one and this one. Everything is except by this minus, so we can move this minus outside, right? We can have this minus and that will be a positive, right? So then I will do the substitution, and it will have 3 the minus outside W, and basically this one is is the normal antiderivative that we know, right? Which is 4/4 minus, right? Closing. And we can substitute back this if needed. Cosine. Okay.